Factoring trinomials. We will look in this section to learn the technique for factoring trinomials of the form ax squared plus bx plus c. Notice the similarities and differences from this section and last section. Last section we focused mainly on trinomials of the form x squared plus bx plus c. So in other words, the coefficient for the x squared in section 2 was always 1. If it wasn't, we saw that we could factor out completely by the GCF, and we had a remaining trinomial factor of the form x squared plus bx plus c. But here we'll look at trinomials ax squared, such as 4x squared minus 3x plus 7, other trinomials that have a coefficient other than 1. Of course, for any trinomial or any polynomial, if we are factoring a polynomial, we should always consider to factor completely. In other words, our first step should always be to look for a greatest common factor, a factor that is shared through all three terms. And then lastly, there are factor trinomials by grouping. Factoring by grouping is the method that we will learn. We will knock out steps 1 and 3, objectives 1 and 3 at the same time. Our grouping method, I will refer to it most often as the AC method of factoring. You can see that the reason why we call it the AC method is because it comes from the coefficients there, A and C, where our first step is to multiply together those coefficients. But we'll get to that in just a moment. We'll start with the first step. Again, why are we learning this here? Techniques for factoring trinomials will help us solve polynomial equations in 6.5. Polynomial functions will be our drive towards college algebra and beyond. Any applied calculus or calculus course will work mainly with polynomial functions. Most often, any typical scenario involving the relationship between two variables or two sets of numbers, such as time and money, such as time and distance, such as cost and unit production, all of these tend to follow a relationship defined by a function that is most often a polynomial. We may have rational functions that define certain real-life scenarios, but more often than not, we will have polynomial functions. So in order to feel comfortable working with polynomial functions, we'll need to know how to factor them to find certain roots of our function that will help us with our information that we're trying to collect. Some warm-up exercises here. For the following exercises, we want to fill in the missing factor. Recall from the last section, we looked at trinomials as the product of two binomials. For example, number 3, the trinomial ax squared plus bx plus c is defined using the variable t, where our value for a is 3, the value of b is 4, and the value of c is negative 15. We see here that they are giving us one of the factors, 3t minus 5. We want to determine what is the factor that should be multiplied to 3t minus 5 in order to get the trinomial 3t squared plus 4t minus 15. We want to also do that for 13 and 18. Determine what factor should multiply to the given factor in order for it to result in the trinomial. Please pause the screen and work through each of these 3 examples, keeping in mind that whatever binomial factor you come up with, you should multiply it to the given factor using the FOIL method, combine like terms, and see if it simplifies down to the trinomial given on the left. Our first factor given for number 3 is 3t minus 5. Three t minus 5 is going to multiply some missing factor, and it will result in the trinomial 3t squared plus 4t minus 15. Most often when we multiply binomials, it results in a trinomial. We have a factor here that is a binomial. What should we multiply to get the trinomial? Well, look at the first term, 3t squared, and look at the first term given in this factor here of 3t. We'll go to the full screen. What would need to be multiplied? In other words, when we multiply polynomials, or multiply, in this case, a binomial to some factor, we are going to consider distributing each of the two terms, 3t and negative 5, into the missing factor. What would we need to multiply to 3t in order to get 3t squared? 3t times what is 3t squared? T. So we know that there has to be a factor of t over here because we need to multiply this 3t to something in order to get this term here, and that would be the t. But we also see that there's this real number over here, minus 15. And here there is this real number, minus 5. We need to distribute the minus 5 and get it to multiply something. Negative 5 multiply what number will give us negative 15? That's positive 3. So we include the term plus 3 for a binomial factor t plus 3. So now that we have written this trinomial as the product of two binomials, we want to confirm this. Let's make sure that this is the correct factorization by multiplying them through using our distributive property or our FOIL method. 3t multiply t, 3t multiply the positive 3, and of course this 3t is positive. So we've distributed the 3t to each of these two terms. Now we'll distribute the minus 5. This minus 5 multiply t. This minus 5 multiply positive 3. Three t times t is 3t squared. A positive 3t times 3, or 3 times 3t is 9t. Minus 5 times t, we can write this as minus 5t. Minus 5 times 3, minus 15. Multiplying two binomials, we get 4 terms. We see that the middle two terms are like terms. We have how many t's? I have 9 t's, but I'm taking away 5 of them, so I leave behind 4 t's. Of course, that 4t is positive. Confirming that the product of these two factors does in fact equal the trinomial present. Confirming that the missing factor is t plus 3. We'll look at the second example there. Second example, number 13. We need to multiply 3x minus 1 to some factor in order for it to equal 6x squared minus 23x plus 7. Six x squared minus 23x plus 7. And getting the idea here that, notice that our leading coefficients, it isn't a 1 anymore, right? Last section we saw where a lot of our examples were x squared plus or minus our bx plus or minus our c value. Here, notice that we have an ax squared or an at squared for number 3. We have a coefficient in front of our variable squared other than 1. We have, for number 3, a coefficient of 3. For number 13, we have a coefficient of 6. And of course, for number 18, we have that coefficient of 12 in front of our squared variable or our variable squared. Which means once we get into the bulk of this section, we will need to display some other technique for factoring these trinomials. Here, however, we're just kind of building that assumption, building that idea that for 6x squared, the reason why we're thinking about this, what could we multiply together to give us 6x squared? Well, the product of x and 6x will give us 6x squared. We'll go to the full screen here. X times 6x is 6x squared, but you see here that we are not given these two factors. We are given a 3x factor. So what could we multiply to 3x in order to get 6x squared? Well, 3 times 2 is 6, but 2 times 3x is 6x, so we need to add in an additional factor of x. 2x times 3x is 6x squared. So here we'll write the term 2x. And for the real numbers here, for the constants, we have a positive 7 as our c value. Here we have a negative 1 constant. When distributing this negative 1, we need to multiply it to a real number because we know a real number times a real number will give us the real number 7. What times negative 1 will give us positive 7? Well, negative 1 times positive 7 is negative 7. Therefore, to get the positive 7, we need a negative 7. Negative 1 multiply negative 7 is positive 7. So let's verify our results here. Distribute the 3x to 2x. 3x times 2x is 6x squared. That checks out for the first term. Multiply the outer terms. Distribute the 3x to the negative 7. 3x times negative 7. Negative 7 times 3x is negative 21x. However, we see now that we must distribute the negative 1 to each of these two terms. A negative 1 multiplied 2x is negative 2x. And we see that outer product and the inner product will give us two like terms. And combining these two negative like terms, a negative combined with a negative will get even smaller. Well, that's negative 23x. And that's the term right here. So we see that by multiplying these two binomials together, the product of the first terms gives us that first term. The outer product combined with the inner product gives us that middle term. And now here, multiplying the last terms in our factors, negative 1 multiply negative 7, negative times negative is positive, 1 times 7 is 7. Confirming all three of our terms. Therefore, the missing factor that we need here in order to multiply 3x minus 1 in order to get 6x squared minus 23x plus 7 is the binomial factor 2x minus 7. So a binomial times a binomial, often resulting in the trinomials. To the right, number 18, 12x squared minus 31x plus 20. We are determining this to be a composite trinomial because it is going to factor into the product of two factors here, 3x minus 4 and our missing factor. We are to determine the missing factor. So let's consider, again, reversing our FOIL method steps. What binomial should we FOIL with 3x minus 4 in order to result in the trinomial on the left? We'll go to the full screen. 3x needs to multiply some other term in order to give us the 12x squared, as we've seen. What do we need to multiply to 3x? In order to get to 12x squared, 3 times what number is 12? 3 times 4. How can we go from x to x squared? X squared represents two factors of x. I only have one over here. Let's multiply in another factor of x. 3x times 4x is 12x squared. Now, of course, we see that this minus 4 is also going to multiply the 4x. A minus 4 multiplied 4x is minus 16x. So we're just making a note of that off to the side. Now, a negative 4 is also going to distribute to multiply and give us some number, positive 20. So again, we see here that the trinomial has a positive 20, which means that the factors at some point have two real numbers multiplying together. Negative 4 is a real number because there is no variable attached to it. 3x is a variable expression. Negative 4 is a constant, which means it's a real number. Negative 4 needs to multiply some other number to give us positive 20. It's a negative 5. A negative times a negative number is a positive number. 4 times 5 is 20, so we get positive 20. Now we want to confirm by checking our products. We saw that negative 4 times 4x, that inner product, was a minus 16x. Now what about our outer product? 3x distribute to negative 5. 3x times negative 5, negative 15x. Our inner product and outer product give us like terms that combine together. A negative combined with a negative, combining two negatives, we're going to get even smaller. Negative 16 combined with negative 15. If 16 plus 15 is 31, a negative 15 combined with a negative 16, this gives us a negative 31x. We see that is in fact the middle term here for our trinomial. We also see the negative 4 multiplied negative 5 is positive 20. So this confirms that our missing factor is 4x minus 5. So in this section here, we will learn how to factor trinomials whose leading coefficients are not 1, coefficients other than 1. To see how this works, consider the following setup here. Any trinomial, ax squared plus bx plus c, as we've seen before, trinomials are often factored into the product of two binomials. As we've seen, we need to consider what are the terms that multiply to give us ax squared. Well, it's some number x times some number x to give us ax squared. So we need to first determine what are the factors that are going to multiply together to give us that coefficient of a, and also what are the factors, what are the real numbered constants, the terms there that are real numbers, how are they going to multiply to give us c? So the goal here is to find a combination of factors of a and b, or excuse me, a and c, such that the outer and inner products add up to the middle term bx. Now this is going to be the trial and error method for determining our factorization. This is how I worked it when I was in school. We are given the trinomial 3x squared plus 7x plus 2, and we're being told to factor the trinomial. Again, some trinomials may be prime, so if we cannot find these two binomials that multiply to give us our trinomial, then we can't factor it at all, and we would just say that the trinomial is prime. So how are we going to start here? Well, with 3x squared plus 7x plus 2, let's consider what are some factors for our coefficient a. What are factors for 3? Also, what are factors for our constant c? What are the factors that make up 2? We will go to the full screen here. So factors of a, factors of 3, fortunately for us, 3 is a prime number. The only factors for 3 are 1 and 3. If we're referring to factors 1 and 3 that multiply to give us 3, then for the term 3x squared, this is 1x, or simply x, multiply 3x. Notice there 1x times 3x will give us 3x squared. Is there any other way that we can multiply to get 3x squared? 2x times 2x is 4x squared. 4x times x is 4x squared. So there is no other way that we can have integer coefficients other than 1 and 3. Now what about this c value of 2 here? Again, although 2 is even, it is prime. It's the only even prime integer that we have. How can we rewrite 2 using prime factorization? 2 times 1. Those are our only two factors that make up 2. So the trial and error method says here, let's rewrite the factors of a, which is we only have one set of factors, 1 and 3, and the factors of 2, let's rewrite them as a combination to see if they can in any way combine to give us the 7x. In other words, we want to see if this will factor out into the product of two binomials. Let's write that in. What could the first terms be for each of our binomials? Well, we see here the first terms will multiply to give us 3x squared. Our only list there that gives us the product of 3x squared is x times 3x. And it doesn't matter which way you write this, right? You could write the 3x here, and you could write the x here if you want, because either way, this x, when it distributes to the 3x and vice versa, 3x times x is 3x squared. Now what we want to do here is rewrite this 1 and 2. We need to place them here for the second terms in our binomials. But the question here is, which order do we write it? Do we write it as x plus 2, or do we write it as x plus 1? Do we write it as 3x plus 2, or do we write it as 3x plus 1? That's the trial and error process. The trial says plug it in and see what happens. If it's not correct, it's an error. Move on to the next possibility. Here, for example, let's start by using the 2 and 1 integers. Let's write here x plus 1, and now let's use the 2 here as 3x plus 2. Again, how do I know to use the plus signs there? This 2 and 1 is understood to be positive. Now, of course, I also can consider the possibility that negative 2 multiply negative 1 is also positive 2. This is another set of integers or factors that multiply to give us c, or in this case, positive 2. But if I plug a minus in here, then my inner product and outer product is going to be negative. And the combination of two negative terms is going to give me a negative term, not a positive term. So because all of these are positive here, I can now understand that these need to be plus signs. Because all of these are plus and positive, these would be positive as well. But if this was negative and this was positive, then these would both be negative. If this was positive or negative and this was negative, if this number is negative, then one of these will be positive, one will be negative. But we're positive, let's try it out. X times 3x is 3x squared. X times 2, that's a positive 2x. And now our inner product, 1 times 3x is a positive 3x. And 1 times 2 is 2. So we need to see, will the inner and outer product combine to give us 7x? 2x plus 3x is, well, that's a positive 5x. That's not 7x. So this is not the correct factorization. So what does that mean? It means that this plus 1 and plus 2 here, let's switch them around. Let's try out that factorization and see what we get. Because again, what do we know here? This is trial and error. We know that 2 times 1 gives us 2. So placing them down here, that's our trial. Try them out. Whichever one doesn't work, throw it away. Try to find the one that does work. If you can't find any that work, it just means that your trinomial may not be factorable. So we're going to write x plus 2, and we're going to write 3x plus 1 and see what we get. As we see, distributing FOIL method, x times 3x is still 3x squared. X times 1, well, that's a positive 1x. 2 times 3x is 6x. And then 2 times 1 is 2. So combining the inner product and outer product, 1x and 6x, we get positive 7x, which is our middle term. These two terms match up. We see the product of our first terms is 3x squared. We see that the product of our last terms is in fact 2. So we have correctly factored our trinomial 3x squared plus 7x plus 2 into the product of our two factors, x plus 2 and 3x plus 1. We have two factors because we have two binomials multiplying together for our factorization. We want to know, did we factor completely? Did we completely factor this? Is there any way that we can further factor this trinomial? Well, look at your two factors that you have. X plus 2. Can I factor anything out of x plus 2? The answer is no, right? X has an understood coefficient of 1. The GCF between 1 and 2 is 1. Factoring out of 1 isn't going to help anything. For 3x plus 1, GCF between the 3 and 1 is just 1. Right? 1 is the largest number that will divide into both 1 and 3. Therefore, that's the GCF. There is no variable of x here, so I can't factor out an x with this polynomial, or this binomial here. So I have completely factored this trinomial because the factors that remain here, the x plus 2 and 3x plus 1, are prime. I cannot further factor them. Therefore, we have completely factored our trinomial. Factor the trinomial, 3x squared plus 5x minus 2. So we're on the right side there, number 26. We'll go to the full view. My leading coefficient, A is 3, B is 5, and C is negative 2. The goal here is, for the trial and error method, is to find a combination of factors for A and a combination of factors for C, such that when we combine them, they give us our middle term, B, which is positive 5. Let's see how we do that. What are the factors for 3 here? 3 and 1. Because again, we see there that 3x times x will give us 3x squared. So these will be the first two terms for our binomial factors. The factors for C, well, C in this case is negative, a negative 2. So two numbers that multiply to give us a negative 2, one must be negative, one must be positive. 2 is a prime number, so its factors are 1 and 2. So what are the factors for negative 2? Negative 1 multiplied 2 is negative 2, but we also have positive 1 multiply negative 2. Put that in parentheses to show again that it is a negative factor, negative 2. So those are my only factors that give me minus 2. And I'm working over here with the only factors for 3, which is 3 times 1. This 3 and 1 indicates that the first terms here are 3x and x. So we write them in. Again, we see there 3x times x is going to give us the 3x squared. Now, what here will multiply to give us negative 2? It's these integers here. But now our goal is to take these pairings and plug them in run through the FOIL method and see if we will result in the original trinomial. That will guarantee that we correctly factored our trinomial. Because remember, factoring is the reverse of multiplying. Factoring is the reverse steps of the FOIL method. Let's see what we get here. Plugging in the first pairing, -1 and +2. All right, -1 plus 2. Now I know that 3x times x gives me 3x squared. I know -1 times +2 is -2. So when I plug them in and do this trial and error here, I'm really just checking to see if I get that correct middle pairing. The outer product, 3x times 2, well, that's a positive 6x. My inner product, a -1 multiply x, is a -1x. Positive 6x minus 1x combining to give me a positive 5x. That's my middle term. The positive 5x matches up with my middle term bx there. Therefore, it tells us that our factorization, 3x minus 1 multiply x plus 2, is the correct factorization for our trinomial, 3x squared plus 5x minus 2. There are two prime binomial factors for our trinomial. For the -1 and the +2, the very first thing that we tested happened to work. But what else could we have tested? We chose -1 and +2. We could have plugged in here a +2 and a -1, because that also multiplies to give us the -2. We could have also checked the second pairing here for a +1 and a -2. And if that didn't work, we would switch them around and put the -2 here and the +1 here. So notice there that if you have two pairings, you have to check 4 different times. But for us, luckily, the first pairing that we plugged in, the -1 and the +2, happened to be the correct pairing. Had I chosen the +1 and the -2 and saw that that wasn't the correct pairing, and notice again, why is it not the correct pairing? Let's try it out. Let's say, for example, we chose the +1 and -2 to begin with. That means the +1 goes here, and the -2 goes here. Well, what happens now? Well, 3x times x is still 3x squared. +1 times -2 is still -2. Now let's check our inner and outer product. +1 times x, that's a +1x. 3x times -2 is -6x. So we see combining this +1 and -6 will give us -5x, not +5x. So we needed the opposite signs. We didn't need the +1, we needed the -1. We didn't need the -2, we needed the +2 instead. And again, if you would have switched these around to check all the possible results, for the 3x minus 2 and x plus 1, this is a -2x. This is a positive 3x. Positive 3x minus 2x is plus x. So there's still all these possibilities, right? If this was 3x squared plus x minus 2, then this would have been the correct factorization, because we see here that the outer product is a positive 3x, the inner product is a negative 2x, combining to give us a positive x. So 3x squared plus x minus 2 is this. However, 3x squared plus 5x minus 2, just that itty bitty difference there. Going from plus 1x to plus 5x, our factorization would go from 3x minus 2 and x plus 1 to 3x minus 1 and x plus 2. So very many different possibilities for all of these binomial products, but only one binomial pairing here, the product of 3x minus 1 and x plus 2, these are the only two factors that when you multiply together will give you the original trinomial. Number 34, we're looking at the trinomial 6x squared minus 10x plus 5. We're looking here to factor the trinomial. Again, it may or may not be factorable, but we're going to take a look at the factors for our coefficient a and the factors for our coefficient c. So what are our factors for 6 here? Well, what can multiply to give us 6? We have the obvious 1 times 6. But for 6, 6 is an even number, so we know that 2 is divisible, or 6 is divisible by 2, 2 times 3. Okay, so now we're going to have to work with a few more pairings here. Previously, this has been a 3 or a 2, it's been a prime number. But when this coefficient is composite, we get many more options here. So our trial and error is going to have to go through many more steps. Fortunately for us, in the next few slides, we will be able to see the AC method for factoring that will allow us to have a concrete algorithm. We'll just follow a few steps and we'll be able to get the factorization every time, as opposed to having to bust out all of this arithmetic here in order to check all the possible trials. But we're still going to do that for now. 1 and 6 gives us 6, 2 times 3 gives us 6. What about positive 5? Well, 5 is a prime number, so we have 1 times 5. But something I'm going to be mindful about is this middle term here is negative. So how can I introduce a negative into multiplication? I need a negative sign. I need a negative factor. Well, over here, 1 times 6 and 2 times 3, I wouldn't want to make them negative because then I'm going to be multiplying to get negative x's and negative x's. We'll introduce the negative over here with our constants. It's easier to multiply negatives with real numbers as opposed to variable expressions. So 1 times 5 gives us positive 5, but what else could multiply to give us positive 5? Negative 1 multiply negative 5. Because we know the rule that two negatives will multiply and cancel to give us a positive. A negative times a negative is a positive. 1 times 5 gives us the 5. So we have two pairings here for 5 that we'll want to work with. Keep in mind that if this is negative, positives multiplying positives will only combine to give us positives. So these will be the factors we want to work with. We'll go ahead and X out the 1 and 5 because they can't introduce the negative. How can we multiply to get a positive but combine to get a negative? Oh, well, we need two negative factors that multiply to give us a positive, but will combine together to give us a negative. Now, in the last section, we would say negative 1 and negative 5 combine to give us negative 6. But now we need to consider their combinations with the coefficients for A. So let's go ahead and work that out here. I'm going to go ahead and actually write out some binomial products because we know if this is factorable, it is going to be the product of two binomials. Now, of course, I ask you the question, is there a greatest common factor for these three terms? Can I factor anything out initially? Right, this 5 does not have a variable x attached to it, although these two do. I cannot factor out an x because there is not one here. Looking at the numbers 6, 10, and 5, 5 is a prime number. 5 does divide into 10, but it does not divide into 6. Therefore, I cannot factor out a real number from those three terms either. So there is no GCF, it's just considered 1. That's not going to help us factor. So my only hope for factoring this trinomial is to rewrite it as the product of two binomials. Product of my first terms has to give me 6x squared, but I have multiple choices here. I have the product of 1 and 6, which implies 1x and 6x. X times 6x is 6x squared, but I also have this other pairing here of 2 and 3. So I'm going to go down to the bottom here and write out 2x and 3x as well so that I can test those products as I test the minus 1 and minus 5 with the x and 6x. We can, because these are the only possibilities we have here for our first terms. The 1 and 6 implying x times 6x, or the 2 and 3 implying 2x times 3x. Again, keep in mind, if you write 3x here first, it is okay to write 2x here. Multiplication is commutative, you can switch that around. But once we have them in place, let's keep them there, and let's be mindful of that. We are working with the factors for positive 5. We're working with negative 1 and negative 5 because this middle term is negative. This is negative, this is positive, therefore these two factors must both be negative. When they multiply, it's positive. When they combine, it's negative. So think about this middle term as the combination term. Some things are going to multiply and combine with one another through addition or subtraction to give us this middle term. But for these two terms, things multiply together to give you those terms. So let's start with writing minus 1 and minus 5 and see where it gets us. X times 6x is 6x squared. Negative 1 times negative 5 is positive 5. So we're checking the combination of our inner and outer product. Our outer product, x times negative 5 or negative 5 times x, that is minus 5x. Our inner product, minus 1 times 6x minus 6x. a minus 5x combined with minus 6x, I'm going to get even smaller when I combine two negatives, minus 11x. So my inner and outer product combined to give me a negative 11x, that's not negative 10x. So this is not a possibility. X minus 1 multiplied 6x minus 5, this would actually give us 6x squared minus 11x plus 5. This trinomial factors into the product of these two binomials. But I want this one. So now let's move around the minus 1 and minus 5. Let's put the minus 5 over here. Let's put the minus 1 over here, switching the minus 1 and minus 5. Now, again, we get 6x squared here. We get positive 5 here when we multiply. Our inner product, negative 5 multiply 6x. Negative 5 times 6 is negative 30, so this is negative 30x. That seems to be very big, right? Way too far away from negative 10x. Negative 30x, negative 1x. A negative 30 combined with a negative 1, negative 31. Negative 31x is not negative 10x. So once again, 6x squared minus 31x plus 5. This trinomial will factor into the product of these two binomials. But it's not this one, so we move on. We only had that one pairing for the positive 5, and we tried both pairings for here. We had the minus 1 here, minus 5, then we switched it, and it didn't work for this. So we now have exhausted both of our possibilities for our first terms x and 6x and saw that they did not work for us. So that cannot be the correct pairing for our binomials. Now let's try the 2x and the 3x. Let's see if that's the case, because 2x times 3x gives us the 6x squared. Let's see how they work with our factors minus 1 and minus 5. 2x times 3x is 6x squared. Negative 1 times negative 5 is positive 5. Our inner product, minus 1 times 3x, is minus 3x. A 2x times negative 5, or in other words, negative 5 times 2 times x, is negative 10x. Negative 3 and negative 10 combine to give us negative 13x. So again, this product here is 6x squared minus 13x plus 5, not the minus 10x that we want. So let's go ahead one more time. Last thing we have to check here is switching to minus 1 and minus 5. So now switching to minus 1 and minus 5, we look at 2x minus 5 multiply 3x minus 1, and we see again that our inner product, minus 5 times 3x, is minus 15x. A 2x times negative 1, negative 2x. Negative 15 and negative 2 combine to give us the negative 17x. So once more, this binomial product here represents 6x squared minus 17x plus 5. However, that is not minus 10x. Therefore, this is not the correct factorization for our original trinomial. And we have exhausted all possibilities. It can't be 1 and 5, because a plus 1 and plus 5, that will only give us a positive combination and not a negative combination. The only factors to check here are negative 1 and negative 5. We checked those factors and we switched them as well. We put the negative 1 here, negative 5 here. We FOILed and saw that it wasn't the trinomial. We switched the minus 1 and minus 5, FOILed, and saw that it wasn't the trinomial that's listed. This tells us, because we went through the trial and error method for each possible pairing and each possible combination and got no results, this is not the same trinomial. We got results. We saw other trinomials that were factorable, but in this case here, we could not find the correct pairing for 6x squared minus 10x plus 5. Therefore, you know what's coming here. This trinomial is prime. It cannot be factored. we can always rewrite this trinomial as the trinomial times 1. We can always introduce a factor of 1, and then we can make fun of 1 and rewrite it as something like x over x. We can always, we can always introduce these factors, but as it stands, this trinomial itself cannot be further broken down. There are no binomials with integer coefficients that will FOIL to give you this trinomial. It is prime.